Alright everyone, so today we're going to be starting off Unit 9 with Lesson 9.1, which is Introduction to Statistics. Okay, so let's talk about some statistics vocabulary. So statistics is the art and science of using sample data to understand something about a particular population in the context of uncertainty. It is the science of learning from data. So statistics is really about taking a sample from some population, collecting data from the sample, numerically describing it, and then using the data to infer things about the larger population. So if you have a population, for example, the United States at about 100 million, you take a select amount of those people, maybe you take 100,000, and you take those people as your sample. And then you use statistics to find standard mean or standard deviation of whatever you're studying. And then you use statistical inference to come up with a parameter that we can apply to the larger population. So here's just a simple example. Say we take a city of maybe 30,000 people, and we take 3,000 of those people and we ask them, do you like dogs? And we take that data to apply what percent of the larger population likes dogs in the city, is basically what that's saying. So, there are several types of statistical studies that we use, and there are three distinct types that you have to know the vocabulary of to be able to determine which. A survey is a questioning technique used to collect information. Surveying a part of the population is called a sample, and surveying an entire population is called the census. So, basically a census, like in the most simple form, is like when they have people come and you have to say how many people live in your household and their ages. Okay, that's what a census is. Survey can be done in the form of a questionnaire. It can be done in the form of a verbal survey, a written survey. And then an observational study are individuals observed with no attempt to influence the results, in the sense that the researcher watches and records without any interaction with the individual. So observational studies are studying things that people are already doing, okay? So you're not like imposing something on them. And an experimental study is where you're actually imposing an experiment on someone or a group. A random sample is divided into two random groups, with one group having something intentionally done to them. So there's the experimental group, the group that receives the treatment, and the control group, the group that receives a false treatment or a placebo. Everybody know what a placebo is? So for anybody who doesn't know, I'll just mention, a placebo is like you think you're receiving a pill that does something, but it's basically just, it doesn't actually do anything. It's like a sugar pill, okay? And the reason we use the placebo is because we don't want it to affect the results, because it actually affects the results if people think they're receiving a treatment when they aren't. So an example of this more recently would be like the COVID-19 vaccine. There were people who volunteered to be part of the experiment, and some of those people received the vaccine, and some of those people also received no vaccine at all. They thought they received the vaccine. Those would be the control group, just to give you an example of what that is. So the way I always remember it too is experiments have ethical possibilities, like of what could be unethical. So for example, it's pretty hard for a survey or an observational study to be unethical. I mean, it's possible, but it's less likely. An experimental study is more likely to have a possibility of being unethical. Okay? So for example, if you experiment, with babies and tobacco use or something like that, it's pretty unethical, right? So you have to think of, that's kind of the way to remember it's experimental. So determine whether each situation below describes a survey, an observation study, or an experimental study. Underline, we're not going to underline, we're just going to fill in. Underline the sample, I guess we'll underline it, and then suggest a general population from which the sample may have been selected. So we're going to be determining the sample and then the population we're actually studying based on the sample. So it says here, a record label randomly selects 50 teenagers from Oviedo High School to view 3 album design covers and then records their reactions when they see the designs. So of these 3 study types, what do you think this one is?
Observational.
Good. This is observational. We're not imposing anything on them. We're not asking them to fill out a survey. We're simply just I was going to write Oviedo. We're simply just observing them. So this is observational. And the group of the sample that we're taking is 50 teenagers from Oviedo High School. That's going to be our sample, okay? Now, the population is basically what's the broader population that we picked the sample to study?
Oviedo High School.
Good, Oviedo High School, specifically students. So do you guys understand the difference between a sample and a population? Okay.
A sample is a small group from the population. Correct?
Exactly. Good. Perfect. So a city council sends out a questionnaire to 200 random residents asking what items they will recycle if the city starts a recycling program. So what type of study would this be?
Experimental.
Survey. Good. So we're not taking one group, giving them one thing, and then the other group not receiving a placebo. This is simply a survey. A questionnaire is just another name for a survey. And then we'll underline the sample, which is 200 random residents of a city. I'll just say of a city, okay? And what would be the larger population here?
The city.
Yeah, the city residents, right? So that would be the city residents. So scientists studied the behavior of one group of dogs given a new heartworm medication and another group of dogs not given the heartworm medication. So what type would this be?
Experimental.
Good, experimental. Because you're taking one group, you're giving them something to see how they react, and the other group receives basically a placebo. So the group that we're looking for, our sample is one group of dogs.
I have a question.
Sure.
Are we gonna actually be doing math today? Cause I'm looking at the back and it's more
Like
math.
arithmetic? There's only one question we're gonna do like that.
No, man. This is what we should have been learning.
I mean,
Right.
sign up for probability and statistics next year if you like this. But we are gonna be doing math in this unit, yes. This is just an introduction. So what's the general population that we're looking at here? All dogs. All dogs. So the yearbook committee conducts a poll of 100 Oviedo students to determine whether they'd prefer a print or digital yearbook or both. What study type is this?
Survey.
Good. Survey. Our sample is 100 Oviedo students. And what's the population?
All Oviedo students.
Good. I should have put an S on this one. All right, so far good? Anybody need any more time on this? Okay. So now we're going to look at this one and determine whether a survey, experiment, or observation is appropriate for each situation described. So now we're going to be looking at the types of things that you want to study and which type of statistical collection basically is going to be most useful. So a pharmaceutical company wants to test whether or not a new medication is or medicine is effective. What would be the best way to test that?
Experiment.
Good, an experiment. Because if we just survey random people, is this medicine effective? They're not going to know the answer to that, right? We have to do an experiment. And we can't observe them because they're not taking the medication to be observed yet. A news organization wants to gauge opinions of local citizens on a presidential election. Good. It'd have to be survey because observing people isn't going to help tell you, what they. I mean, it might, but. A company wants to. This one's tricky. A company wants to study smokers and non-smokers to determine if smoking affects lung capacity. Who said observational? Good. So let's talk about why it's not the other types. So this is observational because we're looking at smokers and non-smokers. So we're looking at people who already smoke, right? We're not taking people and making them smoke. And anybody know why we wouldn't do an experiment here?
It would be unethical.
Good. It would be unethical because smoking is
Good.
bad. It's unhealthy, right? So that would be unethical to have people smoke just for a survey. So it's more ethical to have people who already choose to smoke on their own, and then we observe what happens. And it's not a survey because we're not asking them to fill out anything or answer questions. We're just simply observing them. A pet chain wants to determine if customers would join a rewards program for a small fee. Yeah, the best way we could observe this would be just to give a survey at the pet store or whatever it is. So yeah, you just give a survey. Observing people at the store isn't really going to help tell you this. So, let's talk about bias. So bias tends to favor a certain outcome or certain outcomes, and is an error that results in misrepresentation of a population. A random sample where every member of a population being studied has an equal chance of being selected reduces the possibility of bias. Additionally, surveys should not, and these are things that you're going to use to determine if things are biased, be confusing or wordy, cause a strong reaction, encourage certain responses, we call this a leading question, or address more than one issue, which is what we call double-barreled. So I want to talk a little bit about, before we get into bias, when we think of bias in just in social life, we think of being biased as you're being negative. In math, bias can be intentional or unintentional bias. So you could have somebody who's trying to be unethical about their study and actually be biased, or an unintentional bias. They're really trying to have an ethical study, but they didn't recognize the bias within the study. And you have to keep in mind that not all of these are going to be them trying to sabotage the study. It's just accidental bias. So just something to think about.
This is a weird, math science overlap.
It is, right? Yeah, statistics is kind of like where math and science overlap. So, yep. Determine if the following reflects a random sample that can be used to generalize across a larger population. So, we're basically determine if these are what we call random or non-random. Random means it's unbiased, and non-random means it wouldn't be biased. So, asking every player at a football game what sport should be broadcast on TV. Biased or unbiased? Biased, so we call this a non-random sample.
I think they all said soccer.
That would have been my answer.
So, for example, this one, we don't know if the person was just not thinking about it or if they were purposely trying to sabotage the study to make it look like football players. That's another big thing when you take science class or statistics. You have to figure out, sometimes there'll be a whole study that's all biased, and it just doesn't have any validity, right? So surveying people going into a pet store to find out if the city's residents support building a dog park.
No.
Good. Why would this be non-random?
They probably have a pet.
Exactly. We're taking a group of people who probably have pets and asking them. It'd be more less biased to just ask a random population of people in the city. So the last one would be calling 100 random selected phone numbers to ask the residents their opinion about local sales tax.
That seems
That's
random.
random.
That's pretty random. Now, the reason I want to talk about this specifically is generally I would say it's random. Some things can kind of be on the cusp of being random and not random, and we're going to talk about one of those situations that you might not recognize as being random, probably an unintentional bias. So if you were conducting a survey of political preferences for likely voters in an upcoming election, why would dialing 10,000 randomly generated landline phone numbers introduce a bias into the sampling?
Because
Certain area, that's a possibility. Anybody else have we're randomly generating landlines, so it's anywhere in the country. So not necessarily an area issue. Okay, that's true. Yeah, they might not be able to vote. Okay. What else? I'm just asking, do any of you use your landline at home?
I don't think we have one.
For facts.
You probably don't use it. But who would use a landline? What people usually do use it?
We have a landline, but
Yeah. You might have a landline. Some people do. Some people, but who's more likely to have a landline?
Older people.
Older people. So what's the problem with this?
Only old people.
It's more geared toward older population, right? So, not everyone has a landline, especially with cell phone. geared toward older population. So this is one of those situations where at first you might think, yeah, it's randomly selecting, but you have to be careful because there can be some bias. And sometimes it's not necessarily like a lot of math is, it's not necessarily always black and white. So you do have to be careful of this. And these are the kind of things are what we would call like an unintentional bias that would typically happen. Somebody might not think of this when they're just doing a study. So does anybody have any questions about that? All right, let's try the next page. So determine whether each is biased or unbiased. If biased, explain your reasoning. So that little chart with the bullets on bias is going to be really helpful for you here. Okay, so let's talk about these situations. So if I asked whoever, do you agree that the cafeteria should serve more healthful food? Biased or unbiased question?
That's biased, because can't define healthful.
It's not that we can't define it, but we're starting it with a leading question. So, leading questions can make you start, basically it leads you to picking a certain way. So you can't lead with a leading question like that. So let's say for B, assuming we just ask random population, like we just pick people at random, biased or unbiased, how often do you exercise?
Random, or non-biased.
Non-biased. Now this would be biased if I did what, for example? Yeah, if I asked people at a gym, or asked people at like a sporting event, or something like related to fitness and health, or like exercise related, then it would be biased. But if I just pick randomly, no, it's not biased. So, do you book or travel online to save money? Why is this biased?
Leading questions.
Yeah, it's trying to tell you. It's a leading question. We're trying to say, like, at that point, you're gonna make them feel silly for being like, well, if I don't book online. Am I doing it wrong? Like you're basically telling them that they're going to save money online, so it's kind of like pushing them to pick that selection, right? Do you watch exciting action movies or boring documentaries? Why is this one biased?
Because of the
Good, it's a strong reaction, is what we would say. So who's going to say that they watch documentaries after you have that? You ask them that way. Like, it's just, I mean, I would still say yes, but some people are going to be more pressured to say no, right?
Yeah, because they're given a peer pressure.
Well, they must have not seen the Discovery Channel.
It's
That
boring.
is not boring. That's not boring. Once you see a sea lion and a penguin.
TLC, the Learning Channel is my favorite.
I like, there's a lot of good documentaries out there. I'm not saying this, okay? I did not endorse this question. How many glasses of water do you drink each day? We're asking a random population.
That's non-biased.
Good, this is non-biased. Unless I went to a water factory, I don't know.
Oh, water?
Unless I went to the Dasani bottling company. I mean,
People should not drink water. People don't deserve water.
all right, so which is the better horror movie franchise? Halloween or Friday the 13th?
Halloween, 100%.
Well, I'm glad you guys think so, but this is biased.
How is it a
How is that
bias?
biased? I was just asking.
Because they're asking about horror movie franchises in general, and then they give you two choices.
I was in
Yeah, this one is kind of confusing because you have to, if they just were asking you, yeah, they're basically asking you about horror movie franchise and then picking the two for you.
I guess so.
But I see what you mean. Like if it were straight up like of the two horror movies, which one is better? That would be okay. How likely are you to go out for dinner and a movie this weekend?
bias.
Good. Why?
Whose wife wrote that?
So this is what we call double-barreled. So this is asking two things at the same time. And this is one of those things that's it's an unintentional bias, typically. And what the problem with this is, it actually leads to really inaccurate statistics when we do this. Because now we're pulling two things that might not really be related into one category. Okay, so you got to be careful with double barrel. Was our customer support team not unhelpful in solving your issue?
Just confusing. They could have said, were they helpful? That's like, towards
Why can't you ask that then?
Yeah, so this is biased for several reasons. It's confusing, first of all. And we could also probably say that this might be a leading question, right? That one's, but it's definitely confusing. Not unhelpful, like double negative, that's confusing.
They must be really like actually like terrible if they're trying to like trick you to send.
They're trying to they do that sometimes because they want you to pick a certain way. In surveys, you'll see that they try to confuse you with what they're asking.
Sorry, I hate that.
Right? It's annoying, and you can tell them now that this is bias. Everybody good with this page?
Yeah.
All right, so now we're going to look at some statistics from samples and see if we can figure out what we can tell about what we learned. So, Tasty Treats Bakery asked a random sample of 100 seniors at Oviedo High School the question, do you prefer chocolate or butterscotch Tasty Treats? 42% said they preferred chocolate. Based on this data, which of the following conclusions are valid? About 42% of all students at Oviedo High School prefer chocolate. About 42% of all seniors Oviedo High School students prefer chocolate. Or 42% of the sample prefer chocolate. Nothing can be inferred from the sample about the population. Who thinks it's the first one? Who thinks it's the second one? Who thinks it's the third one? It's actually the second one. So I want to explain why this is. So it's not the first one. That one's the obvious one out. Why is that the obvious one out?
Because we're not talking about it.
Yeah, we only asked seniors, and then we tried to apply that to the whole population, right? Now, the reason it's not the last one is do you see any bias in this survey off the bat?
I mean, it only gives you two options. It's like
So this is one of those situations where we're asking one or the other. We're not saying, of all the Tasty Treats, do you prefer chocolate or butterscotch? So this is okay to ask two because you're specifically only asking about the two. We're not looking at the other ones at all. So this survey is unbiased, which means that the data we collect from it is probably applicable to the population, right? Now, it doesn't mean it's necessarily applicable. It doesn't mean it's necessarily always going to be right. But it's not that we can't infer nothing about the population. That's like too strong to say nothing. So it would have to be that we can assume that approximately 42%. In statistics, you always take with a grain of salt, okay? All the time. The library is trying to decide which book to feature in next month's Youth Adult Club, Salt to the Sea, or Sun is Also a Star. Which of the following methods would allow the library to make a valid conclusion about which book to feature? Ask 120 randomly selected people from a list of young adults registered to the library, or ask 120 selected people from a list of all people at the library. Who says the first one?
It's gonna be the second.
It's the first one. Why would I ask all the people if I'm specifically trying to figure out the young adult book club? Like, we don't, no offense, but we don't really care what the 80-year-old people prefer when we're talking about a young adult book club, right? And if they have an 80-year-old book club, then we would ask them. We don't care about what the young adults prefer. So, based on what we're looking at. So the last one, we're going to be using some probability knowledge here. So it says here, Emmanuel surveyed a random sample of 50 Auto Wheel magazine subscribers about the number of cars they own. Of the subscribers surveyed, 15 owned fewer than 2 vehicles. There are 2,500 subscribers to the Auto Wheel magazine. Based on the data, what is the reasonable estimate for the number of Auto Wheel magazine subscribers who own fewer than 2 vehicles? So from this, we can get a percentage or a decimal about how many of the people surveyed had 2 vehicles? So how many people did we sample?
50.
And of those, how many had 2 vehicles?
15.
Good.
No, it's 40, no, 35.
No, we're talking about people who did own fewer than 2.
Oh.
If you were talking about people who owned more than, yeah, then you'd be right. But yeah, it's not, yeah, it's more simple than that. So this is 0.3, or 30%. And how can we apply this to the larger population? Good. We can take a larger amount of people who subscribe, multiply that by the decimal, and figure out about how many of them probably own fewer than 2, right? So I think it's 750. So we can say 750 subscribers likely own fewer than 2. So why did I have to say likely?
Because it's not an exact number.
Yeah, we didn't just survey all of them. In this case, you probably could have, but yeah, likely. And we could survey them all and compare it. So you have the rest of the period.